Now we would like to hear a few words from our director sir on this regard. Sir, please.
Good afternoon to all of you. Professor Subrata Mukherjee from IPR Ahmedabad, my esteemed colleagues. We are honored to have his presence here today, and I have learned that he was visiting Malda for a personal business. So when I came to know that he is here and then his background is known to me, and we have somehow connected to the western part of the country. So I thought his lecture would be an excellent opportunity for all of us to know what is going on in the country at present. And the topic he has chosen also for this lecture is so much, layman kind of topic, so that maybe all of us can understand. And perhaps only one person who can understand better maybe Devrup, because he has a little bit of closeness to the work that he is going to talk here. And I once again extend a warm welcome to Professor Subrata Mukherjee. And thank you very much for sparing your time here. And I wish all of you enjoy the lecture and then gain something. Okay, if we can, take it forward, catch a point and then try to work on it, he is there to help us. Okay, and then we can do wonders with such guidance. Okay, with that I conclude my remarks. Thank you very much once again, and I think they will continue the program.
Now I would request Dr. Kaushik Paul sir to felicitate Honorable Director sir with a flower bouquet. Okay, sir. Okay, thank you, sir. It is time we welcome a speaker on board. A brief introduction goes as Professor Subrata Mukherjee, Senior Professor H, Dean Administration and Head, LIGO Division, ex-Dean Academics and ex-Head FCIPT Division, Institute for Plasma Research, an aided institute of Department of Atomic Energy, Gandhinagar, Gujarat. He holds a doctorate in experimental plasma science from DAVV, Indore in 1995. He has received some of the very prestigious awards in the field of engineering. He has published 4 book chapters, 162 journals, 16 patents on various aspects of plasma applications. We are very fortunate to have you with sir. Now the dais is yours. Sir, please. Yes, sir.
Up and down.
Full screen, brother. Control keep the
Good afternoon to all of you. Professor Alapati, thanks for the invitation. And I came here because of some personal work, as Professor said. And we have been in discussion for quite some time. And he said that if you come next time with you have some time, please come here. And so today is that time. And what I would actually tell you in the next about 45 minutes or so is primarily an introduction to the subject of plasma, which may not be familiar to many of you, as well as what are the opportunities in societal and applications that plasmas can do. Now, before I tell anything more, that we are under Department of Atomic Energy, and atomic energy mostly has its presence in western and southern part of the country, lesser on the eastern part, and located in Gandhinagar. About this presentation or about the institute, if you want to know, you can write an email to me, or I will be able to guide you to the right person. And let me start with the talk, which is I have described it in this way. And about plasma, some introduction I will give you, and then you will be surprised that plasma is all around us. We just don't know about it. So, if you type plasma in a dictionary and see what is plasma all about, the light is the top one. Sorry, what happened? Top one is the light. Which one? This one. Let's just start from the beginning. I think it went to the end. This is the light. Okay. So, if you look into the dictionary, the fluid part of blood, lymph or milk is plasma, and there is a high temperature ionized gas that is electrically neutral. Now, when I tell electrically neutral, actually we all are electrically neutral. We all know that we are made up of molecules, and molecules have atoms, atoms have electrons and nucleus, but the balance is so good that there is ultimately no net charge. All negative charge is balanced by all positive charge. So, we are in perfect electrical equilibrium. So, that is the reason when two people touch each other, or I touch this thing, I do not get a shock, neither this gets a shock. So, there is no transfer of electrons. So, high temperature ionized gas, that is electrically neutral. Now, if I ask you, we all have tube lights in our home. If I break a tube light, I will not see anything. I will see a glass which has a white coating inside it, and some electrodes at the end. But when we give electricity, like we switch on, and we find a light coming out from the tube light. So, and also our meter starts, showing a reading. So, some current must be flowing. This is all known to us. What happens to the medium which is inside, which looks like gas? Because the matter goes from gas to plasma state. So, it is a tube light which we use, all of us use, matter goes to plasma state in our home itself. I will now come to some more details about it. Now, the word plasma comes from Greek, and it means something molded. Now, Tonks and Langevin, nearly about 100 years before, made a plasma called this, and they actually made a plasma out of a nitrogen gas which looks bright red in color, and they thought that this must have some similarity looking at like blood plasma, and hence they gave the name plasma. Langevin later on got the Nobel Prize also for discovery in this area itself. So, plasma is a quasi-neutral collection of charged particles that exhibit collective behavior. Now, I have tried to keep it as simple so that it does not become difficult for many of you to follow, because as I see the crowd is very mixed, not all are from physics background. Like when I tell collective behavior, like you see the behavior of a mob. Like people, when they are in a mob, they can actually do many things which they will individually never do. So, collective behavior is where individual behavior gets suppressed and behavior of everybody together comes. It is called as collective behavior. Plasma somehow has that property. You disturb something here, somewhere very far away the disturbance starts happening. So, it somehow gets propagated through the medium and things like that. And it is quasi-neutral. Quasi-neutral means it is nearly neutral. And these are certain other properties of plasma. That plasma length has to be more than Debye length, and number of particles, and plasma frequency should be any other frequency, and things like that. Now, these are general ways of how one can look at plasmas, because plasma, as I told you, will have like our tube light. It is a gas which goes to an ionized state and start conducting electricity. If you have to conduct electricity, we all know electrons have to flow in a closed path, then only electricity will happen. like anything, whether it's a fan or this one. That's the reason we at least require 2 wires to run any device, even our mobile charger. The electrons will flow from one, charge the device, and will have to go back. So we at least require 2, in some cases 3, where the third one is for electrical ground, that is mostly with air conditioners or refrigerators. For a mobile charger you have only 2 pins. So basically you require an electron to come from your power station, go through the device and go back. What happens inside the device? Electrons are flowing from one end to another end. If there is a battery, it will charge the battery. If it is a tube light, it will light the tube light. So what happens? Electrons are moving, but from where are the electrons coming? They are coming from the atoms. Atoms get ionized. So you have positive charge and negative charge. They move in opposite direction. So you can actually treat them as 2 fluids, ions and electrons, and you can describe them using Maxwell's equations and things very similar to that. Now let's come to more pictures. Like all the stars that we see around in the night sky, mostly we see only planets which are in our solar system with our naked eye, like Mars or Venus or Brihaspati, that is Jupiter, Saturn. But mostly we don't see any more planets with our naked eye. Then what we see as in the night sky is all stars. Some are near, or say galaxies. Some dots actually are nothing but a galaxy. Like there is a galaxy nowadays visible called as Andromeda galaxy, which is the nearest galaxy to our Akashganga, nearest galaxy. And it looks like a dot, but you can see it with your naked eye. All of them are in plasma state. So our nearest thing in plasma state is the sun, is in plasma state. We have this aurora australis and the aureole borealis, which called as northern lights. If you go to north of Sweden or to the Antarctic region, this type of the colored lights happen typically in the month of September, October onwards for a few months. Lightning, which we see during rains and otherwise, is actually matter going to plasma state. What I am telling that it has actually enormous amount of energy content, that is energy per unit volume is very high. You can use it for doing any wonder. I will just give you more and more examples of that one. Now plasmas, as I told, plasma will comprise of positively charged particles called as ions and negatively charged electrons. They may have different temperatures also. Like normally if I ask you what is the temperature of this room, you will tell 24 degrees. Now we know it is air. Air has nitrogen 80% and oxygen 20%, something else 1 or 2. That means are all nitrogen molecules in this room at 24 degrees centigrade? Very high. And all oxygen molecules at 24 degrees centigrade? Give you more examples. Now comes the question becomes more complex. Air at 24 degrees centigrade was fine. What about nitrogen and oxygen? We will see that nitrogen is also at 24 and oxygen is also at 24. Even if carbon dioxide is there at only 0.1%, that also is at 24. So here I can with one temperature define a combination of gases, each of them having separate temperature. So, but in plasma it may not be like that. The electrons and ions may have different temperature. So we just tell them as T, Tg is the gas temperature and ion temperature. And we define plasma as if the electron temperature is higher than gas and ion temperature, we call it as a cold plasma. So we use this for modifying surfaces and things like that, very simple. But if a situation comes where these 3 temperatures are very similar, we call it as a hot plasma, and this hot plasma is actually very hot. It can melt metals. In fact, we were once approached to make a crematorium using plasma as a source for disposal of dead bodies. We found it take over 5 minutes for a person of 100 kg to get vanished. Just nothing is there. So of course we didn't do that project, but we made our estimates of how much time it will take and things like that. So I'll be giving you some small examples of this and this. and you will find that they are actually trying to solve problems which are actually means affecting our lifestyle. So if we try to understand what is the plasma, don't go by these numbers. We have this aurora, as I said, our tube light, neon light, then solar corona, lightning, sun's core, and here comes the area of interest, which is related with thermonuclear weapons. In fact, many of you know the 1998 India had 5 nuclear, nuclear bombs were there, and out of 5, one of them was a hydrogen bomb. And that was nothing but this so-called, they called thermonuclear weapon is here. One of them that India actually exploded was hydrogen bomb. So that essentially tells that you can use it in another way to generate enough energy from hydrogen only, and I am going to touch upon that also. Only thing one has to look into this, that the temperature scale, don't go by density, solid density somewhere over here, solid density. If you go by temperature, we are talking of extremely high temperature. Only thing that in this type of temperature, if you put 100 Kelvin, we are talking of 1, 2, 3, 4, 5, 6, 7, 8, 10 to the power 8 degree Kelvin. Huge temperature, and actually sun and other things are all over here. Actually the temperatures are very high over there. Now, can we make sun on earth? That is one of the questions. There are a few people who got, Bethe was a scientist nearly about some 70 years back, he got Nobel Prize. He was looking at what is called as the alpha line, basically helium lines. He was doing a spectroscopic measurement of the light which comes from sun, and he was trying to find out from that what happens to the helium lines. There is a subject called spectroscopy, which I think many branches use, to see that what kind of light comes out, and from that light you can tell what is happening inside. So he did that, and he found that with time the helium line, which is called as alpha particle as we know, is actually going up with time. So he concluded there must be a source of alpha generated over there inside the sun or on the surface of the sun. And he told that it is possible if hydrogen, somehow 2 atoms of hydrogen fuse together, hydrogen or its isotopes, which are deuterium and tritium. You must have heard about deuterium and tritium. These are isotopes of hydrogen. If they somehow react, they will produce helium particle and neutrons. So this is the thing, energetic neutrons produce. Now these neutrons move out with an energy of 14.1 million electron volt. So if you can stop these neutrons, that medium will capture the heat and the energy and get heated up. And once you get heat, then we know how to convert to electricity. In fact, all our thermal power station does that. They take the coal, convert it into steam, and from the steam they run a turbine, and from the turbine we get electricity. So that is very common all throughout the country, I mean throughout the world. So if we somehow get heat from somewhere, rest is known. So he proposed, he and his colleagues, that can we have something with the process which is happening in the sun, can we have it on earth? With only thing advantage is that we have to stop the neutrons. Bethe later on got the Nobel Prize for this discovery. He didn't actually propose that we should do it. He only told that there is a possibility. So then comes the idea of people told that if we have to make a plasma, now what happens is, I will just tell you, we all have learnt about a law called as the Coulomb's law. Coulomb's law tells that if like charges will repel each other, unlike charges will attract. Very simple law. We have studied in class 12 or whatever. Now if 2 ions have to come together and fuse, they both are positively charged, so they will repel each other. So you have to give them such a high temperature, they will repel the repulsive force and still overcome the repulsive force and do fusion. So this is done usually in a device called as a tokamak, and in India there are 2 tokamaks, both in my institute, one made of copper and copper coils, another superconducting coils. That is the biggest superconducting installation in the country. We have it in the institute. So there are various, tokamak is nothing but a torus like structure, when we want, we make it in a plasma state, and we can actually, depending on the conditions, can have nuclear fusion reaction also over there. People have found out that if you have to make a nuclear reactor and get energy from tokamak, it's not possible for one country to do it, because that tokamak has to be very large. So there is an association which is of 7 countries in making some device called as ITER, ITER. And ITER has its first plasma fusion to produce nuclear power in somewhere around 27, 28 in that, so about 5-6 years from now. And these are the 7 countries. European Union is actually one country, and they are paying about 40%. All the 6 other countries are paying 10% each. So, we are making the largest plasma reactor of the earth in France. So, what we are very proud about, that India is an equal partner in this activity. So, India is also contributing 10% of the project over here. Okay. So, this is how the reactor looks like or is being built, it is looking like. You can see this is a person standing here. This is just a schematic. So, it is like a 10-storied building in height and a person standing here. This is one reactor. If it becomes successful in 27, 28, even India has a plan of making its own reactor. Every country has a plan, because we will get the entire know-how, because we are partners, and we will be doing it over there. So, this is all very fine about energy and fusion and all those things. Let us come to something very simple. There was an experiment called as, very famous experiment called Miller-Urey experiment, where they were trying to put gases like this, methane, ammonia, water, hydrogen, and put a very high voltage among electrodes and produced this purple color plasma over there. And then they found that amino acids, which are building blocks of protein, are being produced here. So, this was the first experiment, one of the first. They were not trying to do plasma experiments. They were trying to show how amino acid got formed in the earliest part of the universe when it came in. And then they used that unless the matter is in plasma state, this does not happen. You can have these gases independently mixed, nothing will happen. So, this experiment actually tells that even to form the building blocks of life, plasma had played a role even at that point of time, maybe lightning or maybe anything, and then the later on more complex things got formed. I will briefly touch upon 2 applications of plasmas. Of course, the most major application is nuclear fusion, where most of the plasma physicists and technologists of the world are actually linked with. But this is what I will be telling is something which we would be able to appreciate as what happens, what are the applications, what plasmas can do. Now, we never think about this as a surface engineer. I just put a picture over there of we all do this brushing every day. Anything that we do, we try to modify the surface or keep the surface as it is, so that surface functional properties does not change over there. So, all these are actually nothing but surface engineering, whatever we do. Now, again two very popular pictures, only to tell you that surface modification can be 2 types. One is a modification below the surface, another is a modification above the surface. Above the surface means both are surface modifications. Like many a times, like people nowadays when they go out in the sun, they take a sunscreen lotion. It is not supposed to do anything inside the surface. So, it is only that prevents, as long as it is there on the surface, it will prevent maybe 8 hours or something like that. So, our job of surface engineers are that we should have is that branch of science where the surface is modified without affecting the bulk properties. So, we would like to do things in a very gentle manner and modify the surface. Now, I will come and show you some of the applications of that. I would again bring this picture because I only want to modify the surface, not change it in a big way. I will be using that plasma, which is called as cold plasma, where electron temperature is higher than gas or the ion temperature. So this is an actual, these are all that pictures are all of my institute, what work we have done. We do it on, these are you can see a big, means a component, actually this component is of my height, around this. Now you have to increase the life of that component. Now we all have gears in our vehicles or anything. Gear is a certain thing which is moving in this way, and something in connection with it has to move in some way, either in the same direction or in opposite, very easily understandable. What happens, which part of the gear will wear out, because that is the teeth of the gear, because teeth is constantly touching each other, and they have to be exactly touching. Now sometimes you find in the old model scooters and everything, sometimes it is very difficult to lock them. When the Bajaj scooter, you must be remembering, it is not easily, gut, 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 some sound used to come, because the gears are not getting locked. The reason is that the sharp edge has become blunt, and it may not always lock it because it is going to slip it over there. Whereas today's scooters or motorcycles, you see, that problem is not there, because everyone does surface engineering on this. So once the gear is made, one does surface engineering so that it can retain its shape for a very long time, maybe some number, 1 lakh kilometer or something like that. So what essentially this process is about, we call it plasma nitriding, is can we introduce nitrogen on the surface of the component and form what is called as iron nitrides. You know, most components are made of iron or some steel, and major part of steel is iron. Can we form iron nitride, Fe4n, Fe3n as we call it, this phase? This phase is very hard compared to iron itself, and this will increase the life of the component by many a times. We use it even for our hydropower stations. If you know that the water comes, you have to guide the water, that okay, you go to this, when you go to this path and things like that. And most of the rivers in northern part of the country, mostly of Himalayan origin, they carry a lot of silt with it, and silt actually erodes the surface. And just because the Himalayan mountains are much younger compared to other mountains. So what do you do some filtering of the silt and everything, but still micron size silt particles come out. You require that the turbine, whichever is generating the electricity or everything, that surface has to be protected. So we use plasma nitriding as one of the things. There are other techniques also, but plasma nitriding is one of them. So this is how a plasma nitrided surface looks under a microscope. It's typically of the order of fraction of a millimeter is what gets modified on the surface. We all talk of nano powders and things like that. If you remember, let's go 10 years back. We see that the cricketers were having some cream over here, you know. They play in the sun and all those things. And many of them had very strange designs. So they will put a style type of cream. Today you will not find any single cricketer having white type of patch over there. No one. Is it that it was needed at that point of time and not needed now? The answer is no. The reason is today the powders have become smaller in size. And the powder, one of the powder which is used in this cream is titanium dioxide, TiO2, because of its various properties. We have developed technologies for making TiO2 powder whose sizes are in the order of 20 to 40 nanometer in size using plasma based process. And this technology is transferred to now 5 companies in the country who make TiO2 powder. They sell to this manufacturer of these ointments. The TiO2 powder, moment you put it over here, it will look white, and within about a minute or so it will be transparent. Basically the top surface of the skin absorbs the TiO2 powder. Earlier it was bigger in size, so it was not going inside, so it was staying on the surface. So this is a technology of making, basically you make a titanium plasma in an oxygen environment and produce TiO2 nanopowders. But nano means actually nano, 20 nanometer to 40 nanometer, in this range over there. This is a work which we did with in Shibpur near Howrah station. We have this IIEST famous for earlier B College Shibpur was the earlier name. Today it is Indian Institute of Education, Science and Technology over there. And this and also PG Hospital or SSKM Hospital and our institute, we jointly worked on making an atmospheric pressure plasma which is used for curing some of the skin diseases, especially fungus infected some of the skin diseases. And this came in Times of India and everything, it became a big news after. So this is how this plasma looks like. These are some of the properties. You can actually increase the coagulation speed of blood by using this plasma source over there. Now this also came about few years back in Times of India, that actually the doctors used it for curing people on the feet. This is a particular type of this thing called as tinea curcis. It's a infection, usually happens in lower parts of the body, especially for people who sit on on the field for rice plantation. The lower part of the body is usually immersed in water and they pick up this infection, and we have done trial runs from 16 onwards, and still we have patients under observation that whether it is recurring back or not. And whatever the number of people that we have done, we have found that once it gets cured, after that it doesn't come back to that person. These are some applications of plasmas on seed. You can change the germination rate of seed. You can make it such that it will never germinate also. You can increase the speed as well as completely destroy. You can do anything, it will never germinate. So such type of things we do depending on application. And in many of them we don't do everything. We have a collaborating institute which does the biology part of it along with us. I don't know whether you are familiar with this rabbit called as this Angora rabbit, and this one of the hair under a microscope looks like this, and it's usually very smooth. It's so smooth that it is very difficult to make 100% Angora rabbit thread. So what we have done is that we expose it to plasma treatment, and this we did in, and we had put it in Kullu, so that the surface becomes a little bit rough, so that we can make 100% Angora fiber. Now this is actually an export item. You can get 100% Angora dress in the country, which is of course very expensive, but it can be exported at the same time. I will come to the third topic, plasma pyrolysis, waste disposal in an environment friendly manner. The title itself tells that it talks of disposal of waste. Now over here we will use the other type of plasma, which is called as the hot plasma, where 3 of them have nearly same temperature. Now I think you must have heard that just about few days back the central government declared that no single-use plastics would be used in the country. That came as a sort of a rule over there. And of course we don't know what to do with that plastic, and told that anything above 20 microns can be used and things like that. The reason, all we know that plastic is very handy, very cheap, very strong enough also, but at the same time how do we get a problem like this bottle of water? Once we consume it, unless it gets recycled, it's a waste, I mean the bottle part of it. This will probably get recycled, but then not necessarily all plastic packets get recycled. And one of the major problems in the post-monsoon, the flooding of our cities is actually choking of the drain by the plastic, not the drain itself. We have nearly adequate drainage system everywhere. The problem more of is that the drain lines, actually at least in big cities, are choked because of plastic. So how do we dispose such a huge amount of plastic which is there? And if you go like in outside of Calcutta, if you go from this side to the airport, you will see the mount just before you, after Dakshineshwar, you will see it on the right hand side, huge mountain coming up. And if you go after every year, maybe after a few years, you will see that the height has gone up. It is a problem of every city. And there are some places it catches fire also, because it generates methane because of its own internal reaction, and sometimes it will catch fire. When it catches fire, then of course the local people get affected. So we started working on this, that can we develop a fast and cheap process to dispose of any kind of waste. So this is one of the Deonar in Bombay. A few years back it caught fire. Then even Valavasa in Delhi, it caught fire. Then they had to put water and sort of douse it down. So this is a general problem. We all know about this problem. These are some of the landfill sites. It was ultimately, it was initially that okay, we will dig a hole and make it such that things can be full. But they all got full, so now they have all become mountains everywhere. So conventional technology was incineration, which you supply a fuel like means kerosene or some low form of diesel, we call it LDO, and that is used for burning. But gradually this is becoming a process that it will burn and reduce, but what it emits is also equally hazardous. So here comes plasma into picture, that if you are able to make a plasma source at atmospheric pressure and the waste comes inside it and then the waste gets treated and nothing should remain, especially our plastic or other type of bio waste or things which have a calorific value, can they be destroyed and energy be taken. This is where the plasma thing comes over. So this is one of the technologies which this European Pollution Agency has sort of approved this one. So this is the plasma torch. We use various configurations of plasma. In some cases 2 plasma torches, in some cases a graphite, some cases a arc, depending on type of waste and how much to be destroyed in what time. This is an outline of a system. This is where the waste falls. These are some cleaning processes and then it ultimately goes to what we are allowed to release in the environment. There is also a Central Pollution Control Board guideline that we cannot throw anything outside. So we have some restrictions and we have to follow within that. So this is our first small system which Central Pollution Control Board given approval. So this is how it looks like. Your waste actually enters here. This will open at a periodic level, it will enter. This inside is the plasma system, you are not able to see. Then all the gases, they come out, they are sort of filtered, and then finally with this chimney it goes up. We have tried to make it in such a way, we have not made it very complex. An ITI person should be able to operate it and should be able to repair it. So that has been our philosophy in this one. So no hi-fi controls that you require a BTech engineer to run the system, then it becomes non-viable. So this was our first system which Central Pollution Control Board gave approval, but it was meant for biomedical waste. And even till today biomedical waste disposal is our major focus in this one. So these are some of the norms of Central Pollution Control Board, and this is what our system gives over there. And finally MOEF, Ministry of Environment and Forest, have given up this approval that this is now a safe technology for disposal. And I would be very happy to tell that there is a AIMS hospital, Tata Memorial Hospital coming in Varanasi. It's actually a hospital meant for say cancer treatment. Huge hospital. And Varanasi is of course a place where many other installations are coming. So they have taken pyrolysis to dispose all the biomedical waste coming from the cancer hospital, that hospital, and also nearby hospitals within the Varanasi district. So we are building a thing which is like around, it can cater to around 100 kg per hour of biomedical waste, which is like talking about a 1000-bed hospital only for cancer treatment, like that way, that size we are talking about. 1000-bed hospital is a huge hospital. Typical government hospitals are like 300, 400 in that category. So this is a larger 300 kg per hour system, how it looks like and things like that. So global status, this plasma technology is now gradually getting more and more replacing all conventional technologies, because it is very clean, very friendly. Even if you stand beside it, you will not see any smell or nothing over there. So I would tell about some of the students if they are interested, because we also, it's not that only scientists at our place do the work, we rely a lot on students to do the basic research, calculation, optimization and things like that. So BTech third year completed, they can apply for a 6-week IPR summer school. Of course, because of COVID, we had to drop it for 2 years, because otherwise they come, they 6 weeks IPR, we pay them the train fare and local accommodation, also give them some money. Everything is taken care, but in spite of that, there is some money being given. And they also can come and do a 8-semester project can be done. This is also for MTech, MPhil. This project can be done without fellowship. We also have other schemes getting some fellowship on National Fusion Program and everything. It's a limited number, but they can come. If they join IPR, then they can do something which is called as a PhD from Homi Bhabha National Institute. We are now under Homi Bhabha National Institute, so Atomic Energies University, for giving the degree. Or if they have MTech in nuclear, they can start, they can directly come. BTech completed electrical, mechanical, gate cleared candidates can apply for a technical training program. This is another way of getting an employment directly after 1 year training. This we do in collaboration with Bhabha Atomic Research Center in Bombay, where they are selected, then they undergo the training there for 8 months, then come to our institute, and then they are absorbed. And we have a lot of formal collaborations between IPR and universities, where many PhD students of other universities can do research at IPR. So if you have students or any of your faculty wants to do, they can spend some time there and things like that. That's all possible with some form of an MOU and things like that. So plasma surface engineering and emerging techniques. So I am actually concluding my talk. So there are no harmful emissions. We really, because many of the cleaning process requires a usage of water, very minimal or no usage. We can use it as an intermediate of the treated surface, can be made hydrophobic, hydrophilic. And then we are working on a wide variety of subjects over here. Some of them, as you can see, most of them have hardly any physics application. They are all for other non-physics applications, mostly in the field of bio and other sectors over there. Pyrolysis, of course, is one of our flagship projects of the institute, where waste disposal is a major thing. And our aim is to somehow have this first in all the cancer hospitals in the country, because there is a thing that when a surgeon removes some part of a body which is cancerous, even that body part cannot be disposed as a body part which is for other surgery. If somebody has a leg amputation, you will cutting the leg and all. That is one type of biomedical waste. But what is removed as a cancerous waste is much more dangerous than that one. So this disposal, we find that many a times it must be disposed right at the site itself. It's not that you can take it and transport it somewhere else and do, because it has a amount of chemicals. In certain cases, even radiation therapy is given. So even radioactive material may be also inside it. So our model is to work for pyrolysis based systems in most cancer hospitals throughout the country in the long run. And we can also use it for generating waste. If the waste is has some calorific value, you can use it and get electrical energy out of it. And we also try to do very adventurous projects like how to destroy flowers in the temple towns and get energy out of it and things like that. Even disposal of carcass, that is animal dead bodies. It's also, once this animal is dead, it's a biomedical waste now. So how does? So for our institute, this is how it looks like. Very nicely built institute. And these are two tokamaks. One is called as Aditya and SST1. These are our tokamaks are devices, as I told, which are like future nuclear fusion reactors. So though we don't do nuclear fusion reactions here, but with some modifications this can be converted to fusion reactors. And IPR is India's key representative in the ambitious ITER program, the reactor which is being built in France. So for plasma applications, we do it in a separate center. You can get details about it from plasmaindia.com. It's under the institute but in a different campus. And so these are the various technologies, like we build technologies which are like absolutely to be used. So we don't have, it's only, not only transfer, but you can look at the scale and size and everything. They're all like commercial and nearly on every month we transfer one technology or other to some industry. That's it has been the record in the last few years. These are some of the technologies that has been transferred. So this is my last slide, and I hope that this is where we are at IPR, which is in Gandhinagar, very close to Ahmedabad, so the capital of Gujarat. And we have various places in the country our installations, and it is continuously growing. In West Bengal we have a tie-up with IIT Kharagpur, not much on the industry side, because once I was defending in the West Bengal Council of Science and Technology the case for plasma pyrolysis. So we have a DG generator set backing the system. So if in case there is a power failure, the DG set will run it for 2 hours, but will not allow any waste to be fed inside. So it will be locked. You cannot feed any more waste. DG set is only the waste which is inside the reactor has to be destroyed. So then I was asked that if there is no diesel in the DG set, then what happens? I told everything shuts down. So the questions were very strange, not easy to answer. So not so much in Bengal, but in other parts of the country we have a very large plasma applications. Of course, most of it is in Gujarat because that's our place of working. So I would be very happy if you can write to me. You can visit plasmaindia.com or ipr.res.in. Both would be linked websites. And if any one of you shows some interest, want to know more detail about the institute or what plasma is all about, or what are the other applications of plasma, like in the field of sterilization. We are even now working with, there is a medical means college cum hospital called as Actrek in Navi Mumbai, where we are working on this cancer of the mouth. You know, many people take the say gutka or tobacco, and finally it becomes a cancer surgical assessment. How to treat that over there, and whether plasma can be a substitute, not a 100% substitute, plasma plus chemotherapy, whether that can treat this level. So we are entering into all those other areas of cancerous treatment also using plasma for various, as well as disposal of biomedical waste and other things. So thank you very much. If you have specific questions, I'd be happy to answer.
Thank you, sir, for such a nice informative session. So the forum is now open for question answer session. If anybody having any question, may please ask.
Please. Yes, they are different. Plasma flow. Okay, let me.
Okay, your first question is on the quantum state and plasma state. Okay, fine. The plasma state would become that you have this outermost electron. If you take an atom, you have the nucleus in the center, which has proton and neutron, and then you have electrons. If you take a hydrogen atom, you have only one electron. And if this electron is given enough energy so that it goes away, so that I can now call that I have a positively charged ion and a negatively charged electron, then I will call this one atom is ionized. Now if I have lakhs and lakhs of this process happening simultaneously, I will have lakhs of ions and lakhs of electrons, and then electrons would interact with each other and ions would interact with each other, so that I can call electrons as a separate entity and ions as a separate entity. If you do a little bit calculation, if you are familiar with the subject, you would see that I can take an atom, hit it with some energy source and split into ion and electron. But you cannot make an ion and electron, though one is positive and another is negative, they cannot actually recombine on their own. They require a third body to recombine. This is the subject of three-body recombination. So in plasma state, you can actually have things like a plasma. Like if you have a tube light in your home, you switch on, it will blink 2-3 times and then it will come on. But if you just switch off and switch on, it will not blink. It will immediately start. The reason is that there is certain lifetime those species have from ionized state to excited state to ground state. So this is the matter in plasma state. You can describe the entire plasma using classical physics. But in quantum state, there are subjects on quantum plasmas or even solid state plasmas where the plasma is actually in quantized states. So it is not that you can take electrons and take them anywhere. That happens in matter under very, there's one of the slides which I didn't tell you. They are solid densities but at very high temperature to be in plasma state. That is actually matter plasma in quantum state over there. So this is the first one. The second one was how does one say measure high temperature? All the measurement of high temperature is by spectroscopy. Now spectroscopy conventionally we use say visible spectroscopy. Like if you look at what Bethe's experiment on light coming from sun, he was looking at the helium line, or we call it alpha line as it is coming. It is in the visible range. But if I want to go and, so this is visible spectroscopy, is the simplest spectroscopy which we do. It is nothing, even if I put a prism, it will give you the 7 lights. But later on, if you want to go to the higher order states, you have to go for X-ray spectroscopy or gamma ray spectroscopy. So with spectroscopy, you can actually tell with very limited error, like maybe few percent plus minus error, the exact the temperature as well as the species also. That is the second. And thirdly is the flow of plasma. The flow of plasma would probably be determined. Now remember, see that as I told that these are charged particles. So electrons are charged particles. An atom which lost the electron is ion, positively charged, are charged particles. And charged particles are governed by, the motion of charged particles is by Newton's laws and by the Maxwell's equation. Basically electric and magnetic field. You can actually take particles from here to there. Just transport it. Like I showed the picture of a tokamak, which is a torus. Torus is actually infinite in this direction. If a particle starts moving, it will not know when it is ending because it is a torus in that structure. What we have to do is that in the process it is interacting with other particles and move away from the trajectory. You put a magnetic field in this direction. So basically the coils like this way, this way, this way. The magnetic field will be this, that the particle will go on moving and moving and moving like this. It's like for it an infinite path to roam around. So electric and magnetic fields, like what we call as Maxwell's equations and Newton's laws, are enough to describe most plasmas that we see around us. And you can use it for flow also.
We require high temperatures, sir. We always require high temperature, high amount of energy.
You require high amount of energy. you do not require high temperature. The plasma will use, when the plasma forms, it has a very high temperature. I'll give you one example. Like many people smoke, and we know that the top part of the smoke is at a very high temperature. It is glowing, and the ash falls on our hand. But do we get any feeling that it is so hot? Answer is no. So it is not the heat content, it is the total amount of heat which it has. If you look at the particles that I told, the number of electrons per unit volume is much less. But those less number of particles are at a very high temperature. Like our tube light. The electrons in the tube light are having a temperature of around 6000 degrees centigrade, means measured value. However, the number of such electrons are very few compared to the gas. Glass will typically, glass of the tube light will melt typically around 350 to 400. It will start getting deformed. So even 350 doesn't reach. You can actually touch the tube light while it is on, not the ends. You will get an electric shock, but the glass part you can touch. So that means it is very close to room temperature or our body temperature. Yes. You go a few slides back. Yes, they are formed. Go back. There is actually a table. Out जाइए. हाँ, here, just wait over here. You can see these dioxin and furans which are there. This is the CPCB standard. This is the standard of USA. Our Central Pollution Control Board has adopted this standard, these numbers. And this is from our plasma pyrolysis system. What happens is that when you destroy plastic, you can be very selective. I will only destroy this. Your PVC is going to come in the picture. And these PVCs which are there, they will generate this one. So our quenching rate of the gas from 700 to 800 degrees to about 70 degrees, there is a particular time that within this time the entire gas has to be quenched. So our scrubber is designed in such way, if you remember that it goes, there is a pollution. It is not that there is nothing generated. So if you quench at a certain rate, your generation rate is much low, lesser than the standard. It is not zero, it will never be zero. But PVC usage is gradually going down globally because of this disposal problem. PVC usage is going down. In fact, many of the tubes which we use even for biosector, like feeding the blood and everything, saline water, that also is getting replaced from PVC tubes to normal, the other material. Yes. What essentially biodegradable essentially would mean that these are things which are mostly of organic nature, and what many people have done, I don't have an offhand answer, so my answer will be more of a guesswork. What essentially are done is that they use binders over there, and we have treated binders, and we found that if the binder is treated rightly, it can give a surface much better. I'll tell that we did something for a company in South India for making small filters for water. So these are basically active carbon filters over there. So they were trying to make a water filter. You have water on the top and this filter here, and then you have drinking water below. And this filter has to be changed once in a week or something like that. No electricity, nothing over there. And they had this problem of that this was very weak and fragile and everything. So we did this treatment of the binder. This is a company called Filtrex Technology, which only makes filters. And after that we found, after doing the plasma treatment, it was very fast, very efficient and very strong. So these binders which you use for making your biodegradable thing can be one thing. See, one of the things which I showed in one of the previous slide. You can use plasma to activate a surface to make it hydrophilic to hydrophobic. Like something which doesn't like water can actually start liking water, or the other way around, something which likes water can be made such a way that it will not like water. So water will just roll on top of it without giving an imprint, like the lotus leaf as we call. So we can have a combination of these two over there, and that may help probably. No, there is no oxygen. Whatever, because it is at atmospheric pressure, obviously when you enter and put some waste, something will go in, but there is no oxygen. Means we are not feeding. Whatever goes with the waste will go. There are all. It is assisted. We have various models. I showed the one which is very popular. You have even what you call a conveyor belt mechanism also. The one we are making in Varanasi is conveyor belt. So you feed the waste, because the top of the plasma reactor is at nearly like 3-story building. So waste is all fed here, and it's a continuous conveyor belt, and this waste goes. Now, if the Central Pollution Control Board has given some guideline that body parts to be put in yellow colored way, this, and surgeon's dress and gloves and all those things in another color bin. So you put it, and they will come sealed from the hospital. This is a rule. It is segregated in the hospital itself. It's not mixed in the hospital. Segregated, then they seal it. That sealed thing comes to us. And ideally we are not supposed to open that one. No one is supposed to open, because many of the waste is not easy, should not be handled by untrained people. Untrained means we all are untrained. I'll put it in that way. We are not trained to handle biomedical waste. So radioactive material, it doesn't do. Below a certain level only radioactive material is allowed inside it, because the plasma doesn't work on radioactive material. It can only make the entire, suppose the radioactive material is, if there is a body part which has radioactive material, it will dispose of the body part, so radioactive material will come in a slag form but get concentrated. But it will not, we cannot do anything to the radioactivity. You cannot do anything. See, at the moment our main focus is on biomedical waste disposal. That is the main focus. In Bombay, Municipal Corporation is putting the first plasma system for disposal of municipal waste. Again, segregated municipal waste. Municipal waste comes in everything. You have plastic, stones, loha, anything comes in municipal waste. If you try to dispose everything, the cost goes up. It is better to do a segregation. So there is one company in Bombay which is using artificial intelligence based sorting. It uses a 2D, 3D imaging technique, and it trains itself and can actually segregate. And reasonably well it can segregate. And then we, along with Bhabha Atomic Research Center, are designing a reactor which can handle a huge amount of municipal waste over there. So that is coming, but in biomedical waste is our main focus. And this 300 kg per hour which is coming up in Varanasi, it's actually Atomic Energy putting in the Varanasi main cancer hospital. That is around 10 crore, if I remember correctly, around 10 crore or something of that order. But that's everything. You only get the land, even making the building and making the shed and assembly running for 1 year, all that is probably included in that. No. That I didn't tell. I told you waste. Cancerous, whatever you dispose of the waste. See, I will tell you what some of the doctors told that what plasmas can do is that many of they actually surgically remove some part of the body which is cancerous. And then they scrape the doctor uses all his experience and intelligence cut some portion, and then removing the remaining portion, they do some sort of a scraping, and they do an analysis to see whether malignant cells are still there or not. If it is there, they cut a little bit more. This is what is conventionally done. Once they are very sure nothing is there, then they stitch it up and things like that. What we are telling that even though you are confident nothing is there, here now you use the plasma surface and it will basically deactivate all the things whichever is there on the surface. Our body cells react very slowly. Cancerous cells react very fast. So they will try to fight with the plasma and they will get killed with the plasma. Our body cells will not get killed. They will decay very slowly. So this is one of the things that we are proposing. It's not a treatment as such. You can use it as a treatment along with something else. But disposal of biomedical waste is the major focus for us. Yes. Yes, everything. No. The reason it is biomedical waste, but the Central Pollution Control Board in 2016 and then revised in 19, they have come with guidelines. In these guidelines, they are supposed to be melted and reused. Knives, your scissors and anything else, to be melted and reused or to be See, as I told you, if you have a plasma, because of its intense heat source over there, it's so hot, as I told you, like if you put anything, nothing is there. So what you have to do is that if you have a titanium metal, solid metal, you put it in a graphite crucible. It's a big graphite crucible. And you have the plasma torch which is falling on it. And it melts, and the moment you melt and evaporate, there is something called as volume expansion. A gas, a liquid, when it becomes a gas, will fill up this much volume. So it basically forms. So this same, then as they become bigger in the volume, the temperature will drop down. They will start, say, coalescing with each other. So this atom which is flying like this atom, they will mix somewhere in space. If you have enough amount of oxygen, they will form TiO2 over there. Here you have to quench them so that they don't grow any further. So there's an engineering design on how the gas flow happens and things like that. So the plasma part may be very hot, but within 1 meter of it you can actually put your hand. There is no flow. It's nearly close to room temperature. So then they will not grow after that. And what will happen is that they are still particles of 20 to 40 nanometer, but they are in agglomerates form. It is like you have a bunch of sand. I can actually take sand and do like this. It looks like as if one particle. But the moment you impact it, it breaks to individual sand particles. It will become like that. Then we take it, we just store it. Just before the application, we again disperse it in a liquid, which is an evaporating liquid like water. And then you use it for the application which you have. So like for creams and other things, you can, there is a chemical in which you disperse it, and then you use it for making ointments and things like that. You can actually take this particle, TiO2 particle, put it on a surface. Suppose you put coffee on a surface, say white cloth, put coffee. Coffee will dry up, it will give a brown stain. You take this TiO2 particle, mix it with water and apply it on it and keep in sunlight. After 1 or 2 days, you will not find any coffee stain there. There's a surface plasmon resonance happens and things like that happen. So with sunlight and this, you can actually clean it. That also is a project we are working on. Silk saris. There's a South Indian company who has asked us to work on this. Any more questions? Plasma. I have not come across this, but that doesn't mean it cannot be used. I will try to ask my colleagues. bunch of mechanical engineers working on heat exchanger design for other applications. Hmm. We use it for actually now we are working on a project with NTPC on starting the reactor. Because normally if a reactor, when it shuts down, a nuclear reactor means a power station basically. Shuts down, when it starts, it requires a lot of energy to come to that state. We are using plasma to do the initial heating and then feeding coal powder in that. It's not heat exchanger, but you can use it as a sort of starting heat basically. You can also do partial activation of the powder, of the coal powder. So they will ignite more faster when they are put in the oxygen and fuel is put on in that.
Thank you, sir. I would now request Dr. Amarjit Roy to give a vote of thanks. Sir.
Sit down, sit down. If I'm standing, you need not stand. I haven't come across a lecture on plasma, which is so lucid, and it appears that how many things we can do with the application of plasma. The presentation is so nice and made it so simple that plasma phases are little complicated phases. That if you look at them like okay, they have different kind of brain and the cloud will be present in their minds and all. Being a physicist, I don't know whether other physicists agree or not. But we used to look with an awe on these people who are doing plasma research. Because like Sophia was asking questions, you cannot identify, you cannot say where is it. You cannot show us also. Such is the difficulty of research. And then you made it so simple. And so many applications are enlisted. So many socially important projects they are involved in. Really the title I think is perfect. But of course, I'm very glad to know that there are solutions that are going to come up for particularly the municipal waste management of other, because even in Malda, if you travel along that bypass road, one he said, I think somewhere in North Delhi, I have seen one big, one day I was traveling that side and that Alipur side, Narela and Alipur that side. I saw one, it's a road towards Haryana, I think. So I saw one, a truck was moving on somewhere on the top of a hill, big hill. And there was some smell, some burning also was going on. Then I saw that what is this, and then I see all the way up they were dumping that waste. This is all a waste hill. Okay, so the examples he had shown, some of them are really terrifying. And there are places in Vizag, I know one case, that a huge waste dumping ground was there. was not there when they were building some flats there. There were about 500 to 600 flats were built and sold off. And then this mound came up. And then the residents were complaining so badly, and then they were becoming ill. Okay, so the kind of solutions I am listening that they are coming up, it's going to be great. We are going to be living in a more cleaner environment, and then the cities that in every rainy season we say that Bombay is underwater, Delhi is underwater. I hope in another 5 to 10 years we will not see that kind of scenarios. So I am happy that you have chosen such a good topic, and then so that we all can understand and then see the potential of this subject also. So if any of our colleagues are interested, he offered his email also and website. If any of you are interested, we can develop something between IPAR and our institute. So he was telling me that there is an outreach department also. They can conduct some kind of workshops here. And we are a big institute in this region, so we can rope in schools and colleges around here and then organize some workshops with them. So he can help us on that. He has promised already. Okay, so with that, I once again thank him for his time and a wonderful lecture that he has chosen to place before us. Thank you very much.
So, good afternoon everyone. It has been a very informative lecture by Professor Subroto Mukherjee sir. Irrespective of his busy schedule, he has found out a precious time for our college. So I want to thank on behalf of our college and director sir. Thank you sir for coming and delivering this precious lecture. And I want to thank our Honorable Director Sir for arranging an all type of support for this lecture, and as well as all the deans and HODs and faculty members for their support and presence. Thank you sir for your lecture. Thank you sir.
No, I thought that so this is the institute website. You find the outreach activities over there. You will see the outreach on the second
Top left. Top left, second line. Second line.
Second line. Outreach. Outreach.
How many
It's a sign.
or left? Yeah.
So these are the what activities they take, because see this is they go to that place and you can contact, ask the legal works.
Yeah, what he is saying is that they have a outreach section, and then their work is basically networking in the country, and then they keep contacting and they keep going with their equipment to the organizations where interest is shown, and conduct workshops, not only involving the employees and students of that organization, all other educational institutes in the region also. So that is up to the coordinating institute, which can, what all they want to involve in that. So they come with their equipment, we have nothing to spend, only we have to give a hall and some current and water maybe, and maybe thoda chai biscuit dena hoga. Okay, so it's the government initiative, and then it's an opportunity. Okay, so if some of you are interested, please come out with a plan. He is there to help us.
So
He will get us connected to outreach.
so the head of the outreach, I will actually give his phone number. Otherwise you can contact and they are all very helpful people, very nice people. And they go to all throughout the country. They were, in fact, I was telling sir that they were supposed to go to Ladakh, Leh in Ladakh, and it got cancelled because the weather suddenly started degrading. And otherwise, they go to everywhere. Like they'll go to, and usually normally they do not go to the state capital. They go to somewhere off the capital. And the entire truck comes with equipments. They come few days earlier, then they will install. And it is live experiments of all that I said about plasma, effect of magnetic fields. You rotate a magnet and you will see that the entire plasma starts the rotating in front of you. And so you start getting a feeling about what plasmas are. There are people who will tell you. Usually one or two locally language speaking people from the institute also come. Because many students may not follow English. I mean students from high school or other places. So we have speakers from the native language speakers. Like they are going to Kerala in the beginning of, not beginning, it is in the end of August. Last week of August they are going to Kerala. So they have 3 Malayalam speaking people going over there. So you can go through this and then discuss with Director Sir, and if you are interested we can think of holding a program.
Okay, thank you very much for your time.